All right. According to this thingamajig and doohickey, we are live. And I want to say thank you all for being here. It is great to have a conversation with a flat earther and try to get to the bottom of what is really going on. The nameless, faceless they, are they onto something? Are they onto us? We don't know, but I guess we're about to find out. So with that, I have Gio here. So Gio, first, before we start, how would you like to be referred to throughout this call?
Geo works for me. My full name is Giorgio, but everyone just called me Geo because I was a bartender back in the 80s and I would play the video games. I get the high score because I was there all day and you could only put your first three letters. So I would put GIO and the name sort of stuck.
Got it. All right, so we'll refer to you as a Geo, which is going to be kind of weird because we also have a friend that also goes by Geo, who is German, but we will let that weirdness just sit there. Um, and also with us, we have the one, the only AT2 Productions. So he is going to be here just to kind of keep the peace and also to collect questions from the chat if there are any. Also keep track of super chats that come in. I want to make sure that we get to all of them. And so yeah, with all of that out of the way, let's go ahead and get started. So I am going to break the ice by asking a very basic question. And that question is, in your opinion, what is the shape of the earth and why do you think that?
Okay, in my opinion, and hello to everyone listening. I appreciate, as does Red, you dropping by. I believe that the Earth is flat, that it is stationary, and it has a dome over it, which is referred to as the oh dear, now I forget. What do they call it? I'm having a brain cramp already. The firmament, yes, the firmament where the stars, the sun, and the moon are in, and they're rotating above us rather than we rotating around the sun. And I also just want to start by saying, and many of you listening have heard this before, and I don't mean to sound condescending, but every flat earther was once a globe earther. So I totally understand how stupid, how foolish the idea of the flat Earth is, especially if you haven't looked into it deeply or if you've only seen some of the disinformation that's out there. It's really a paradigm shattering subject. So I get the resistance, and yeah, but I believe it's flat and stationary.
All right, so but you say that you believe that's flat, you believe there's a dome, you believe there's a firmament, but the second part of my question is why though? What has convinced you that the earth is flat? What has convinced you that there is a dome? What has convinced you of these things?
The first thing, and now as I was putting the presentation together, the first thing that that came to my mind was the obvious, that it doesn't feel like we're moving. I mean, the model that we're presented is that we're spinning on our axis at 1,000 miles an hour. We're rotating around the sun at 66,000 miles an hour, that the solar system is traveling at 200,000 miles per hour. The Milky Way galaxy is rotating at, I don't even remember. And then we're all going at the speed of the Big Bang. And does it really feel like we're moving? No.
So you're one of the main arguments that you're presenting that is you are unable to feel the motion of an incredibly slow amount of speed, like hardly any speed whatsoever. We can't feel us moving so slow, therefore it's stationary.
Well, no, I wouldn't say 1,000 miles per hour is slow. You know, I live in Ottawa, Canada. We're 45 degrees north of the equator, so pretty well between the equator and the North Pole. I don't feel anything. And my wife, and I'll be going there very soon, is in South America, 3 degrees north of the equator. I don't feel any difference. To say that
It's
1,000 miles per hour is slow and that 66,000 miles per hour is slow, no, I disagree with that, Red. We should
well,
feel
the
something.
reason Well, the reason why I say slow is because the rotation of the Earth is 0.000694 RPM. The rotation around the sun is once every 365 days. Yes, it's slow because revolutions are not measured in miles per hour. They're measured in RPM, or revolutions per unit of time. And when you look at that, the scales show that we are spinning on our axis half as fast as the hour hand on a clock. If you look at the hour hand of a clock, imagine yourself on that hand. You would be feeling nothing. Now imagine you're going twice as slow. You literally take that speed, cut it in half. Now it doesn't look very fast now, does it? Take a basketball and rotate it so slow that it takes 24 hours to make a single trip around. Does that look fast to you?
On a small basketball, you'd hardly notice, but on a Earth that is apparently 24,000 miles in circumference, yeah, if you were staring at your watch, looking at the second hand, you wouldn't notice the speed from 1 second to another as much. But if you're staring at a very big watch, yeah, you'd actually see it quite obviously. So
But we do see it
I
in.
think you're kind of obfuscating here by saying that you're comparing the small little watch to something that's the size of the globe. I don't think that argument works, Red.
Well, the good thing about math is that they can be scaled. The difference in force between the North Pole and the equator is 0.3 of a single percent. 0.3%. That's the force difference. So we're talking about us being able to differentiate between 0.3% difference in terms of the centripetal force that is acting on our body. That is minuscule compared to the downward acceleration of gravity. So I would say that yes, the scales may be different, but the physics is exactly the same, and the revolutions per minute is exactly the same. If we were to look at the numbers and just look at what they're telling us, it becomes obvious that we shouldn't feel anything. We shouldn't feel any movement. By the way, another thing that we're failing to acknowledge here is that you don't feel speed, you feel acceleration. The only time that you're actually going to feel anything is if there is a change in acceleration, a change in velocity. But the Earth is rotating at a constant rate. We're going around the sun at a constant rate. It's constant. There is no shift in speed there, which would then become obvious to everyone. So why would we feel anything in that case?
Well, I keep reading that the Earth actually is not circling the sun perfectly in a circle, but sometimes it's a little wider, or
We're talking
depending.
about a difference of 3% between perihelion and aphelion, a difference of 3%. Again,
Well,
these numbers are incredibly small
they're
when you.
incredibly small. But you know what? If I took a chainsaw to somebody and cut their hand off, they'd feel it. But if I took just a little pin and barely touch, they'd still feel it. Not as much, but I'm sorry. There is not as much of a sensation, but there still should be some.
Well, the only sensation that would be introduced is if there is a drastic change in speed, i.e., acceleration. So that could be a braking, that could be us going faster in our orbit, but there's no mechanism that causes us to do that. And the difference between, like I said, aphelion, perihelion is only 3%. The difference between the North Pole and the equator in terms of the centripetal force acting on you is 0.3%. The revolutions per minute of the Earth is 0.000694 RPM. These are incredibly, incredibly small. And so when you look at these small values, and then you have to keep in mind that these values are at a constant rate, i.e., no acceleration, it becomes obvious that we shouldn't feel anything. In fact, if we did feel something, that would hint that our reality is something other than what the nameless, faceless they have been telling us it is this entire time. If there was such an acceleration, good thing there isn't, because the model doesn't call for that.
So now this rotation that you say, which is minuscule between the pole and the equator, is that relative to the sun?
I'm talking about the rotation of the Earth. So yeah, we can say relative to the sun. So there's this nuance about sidereal day and solar day and blah, blah, blah. Let's just say relative to the
Oh no,
sun,
I'm
just
not
for
getting into that.
simplicity.
You're assuming that the sun is 93 million miles away and that's really big. Based upon that assumption, I could see where your numbers are small, but I'm not assuming that. So for your argument to work, you have to make this automatic assumption that we are 93 million miles away from a very large sun. I don't believe that. So this argument doesn't hold water for me.
So basically, let's then that leads us quite perfectly into the next conversation then, because I think all this kind of hinges around this idea of our model.
Okay.
And this is why I phrased the debate that we were going to have in the way that I did, which is which model best comports with reality. So let's go ahead and just put the velocity and the not feeling anything off to the side, because I could get into ring laser gyros, but then this live chat would be full of thanks Bob memes, and then we would never hear the fucking end of it. So moving on. With the sun, do you believe that the sun is small and local?
I do.
Okay. Now, if I were to have a car right in front of me, like maybe, I don't know, 10, 15 feet away, that car would be a certain size within my field of vision. But if that car were to drive away from me, that car would appear to get smaller as distance increases between me and the car itself. Is that correct?
Correct.
Okay. Does the same thing happen with the sun?
Well, sure. I've seen video of the sun being filmed above the clouds. Okay.
Well, we're talking about angular size here. Now, if I were to record the sun all day long, if the sun is like, I've heard many different figures for this, but let's say 5,000 kilometers in altitude, and let's say it's following over the equator, over the flat Earth, as it would on the equinox, by definition, that's what it would do. Then we should see the sun rise at one angular size, grow to twice the size midday, and then shrink again to half that during sunset. The question is, have you ever seen that happen?
Well, I've noticed during the certain days, well, the sun seems to be larger, and even the moon. And I've seen a lot of footage where I don't know if it's double the size, like you say, but you can actually see as you're filming the sun as it's coming up over the horizon, it's small, and as it approaches you, it just seems to get bigger because it's closer to you.
Okay, understood. In that case, I would like to show you this. This is my observation. I did a video called Observing the Sun to Test the Flat Earth. This is a Nikon P1000, the flat earther camera of choice, with a solar filter on top of it. This tripod is actually a telescope tripod. So it will automatically track the sun throughout the entire day. And you can see the solar face on the display right here. That's how I was keeping an eye on it. Now, now you can see the clock right here. This is a time lapse. So I filmed the sun all day long. And as I skim through this, you can see the angular size of the sun does not change throughout the day all the way between sunrise and sunset. And I actually show a comparison image here. Here's the sun at 8 a.m., which is, morning. Here's the sun at 1:25 p.m., which was solar noon at the time. You can see they are the exact same angular size between both of these frames. So if the sun were small, damn it. All right, am I back? I'm back. I'm back.
Yeah,
Perfect.
sorry, I thought we lost you for a second.
Yeah, okay. Yeah, that's my connection being a shit. Anyway, but as I was saying, we would see a shift in size if the flat Earth model was true. But in reality, we don't see that shift in size. So does this not give you pause when it comes to the idea that the sun is small and local?
Well, I've seen all kinds of video that does show the sun getting larger and smaller as it sets away from us. And not only that, the light seems to follow it like it would be a local sun.
What
Um,
is normally being shown is not the sun, it's the glare of the sun. And normally, when one of the big ones that I've been seeing is the one shared by Deep Inside the Rabbit Hole or Dearth, who is the most disingenuous POS on the face of the internet.
no, don't do
Um,
that. Don't do
oh,
that.
I'm gonna say it because he's very disingenuous. He's a con man. Let's be honest here. He is a con man. But the footage that he shows, the footage that has been making the rounds on the internet, is one, very low quality, and two, does not use a solar filter. What I did with my video, as I will show here in this screenshot, let me just bring it up again. There we are. As you can see, I used an actual solar filter. I zoomed in so that the solar face of the sun occupies a substantial portion of the frame of view. This is something that Deep Inside the Rabbit Hole did not do. And if you don't do this thing, then you are susceptible to glare, and glare is not going to give you an accurate representation of the angular size of the sun. But when I took these precautions and we go through the actual time lapse, we can see that as the day progresses, the sun is not getting any bigger, the sun is not getting any smaller. It is staying the same size within the frame of my camera, no matter what time of day I look at it. There's some distortion very close to the horizon, but that's caused by the atmosphere, and therefore we can't really point to that. But between, like, for example, 8 o'clock in the morning and one close to 1:30 in the afternoon, there's no shift in size whatsoever. That's where this slide comes up, where you see the sun at 8, the sun at 1:25 solar noon. They're the same size. So shouldn't this give us pause that maybe the flat Earth model does not, in fact, comport with reality?
Well, I'd have to take your word for it. I mean, I'd have to assume that you are telling the truth. I also cannot verify if, in fact, the other many videos that I've seen, if they were using one or not as well. If they were using a filter, maybe they were. But you know what? Since I can't say that with absolute certainty, I'm gonna have, I don't want to say something that I can't back. But I've seen enough of them, and um, I've seen enough of them, and to probably say that somebody probably trying to prove this probably would have used one of those filters, but I can't say for a certainty. So I
Well,
hate to talk about something that I can't verify. This was one of the things I try to keep in mind as I was gathering my research. Like, I can't verify that. I'm going to have to take your word for it. But this is something that, you know what, I'm going to look into. I'm going to look in. I will question them. That's it. I will say, did you use a filter?
all right. Let's go on the hypothetical that I'm not totally full of crap here. Let's say I actually did the observation and my video is not just very clever CGI or something like that. And you were also able to verify by doing this observation yourself. Let's say I let you borrow my equipment and you did this yourself and you got the same result that I did. Assuming all of that, would you not think to yourself that the flat Earth model is lacking, especially in this case?
Well, you know what? I have to consider it. Like, I want to take all the information, the truthful information, and that would sort of say, yeah, there's some kind of anomaly here, or maybe it isn't true. Right now, though, I'm on the opposite side of you. I really do. I can see from my eyes, and not everything is a distortion. Every day, the same distortion. No, uh, this is something that you might be assuming. Oh, on this particular day, or I would. It would take a lot of testing for me, and then I would come to a better conclusion. But for now, I don't get this argument. I can see for my own eyes that the sun actually gets a little bit bigger when it's overhead. It's much bigger than when it's just rising. Here in Canada, we have long, beautiful sunsets, and I live right across the river. And I go there and I watch the sun as it just goes away and getting smaller and smaller and smaller significantly. So
Yeah. I would highly recommend not looking at the sun directly with your eyes. That would be really bad. But
well, it's
another
not that
thing
I'm
that I
staring at it continuously, but you know, you're there, you're looking up, and 10 minutes later, you look up, and you can see the noticeable difference in size.
yeah, but here's the thing, your eyes are still susceptible to the same problem that would exist with an unprotected camera, which is you will overpower your eyes with just the brightness of the sun. You will overpower the image sensor when looking at a camera. When you say there is a significant change, when you say there is a significant change, then that should easily be demonstratable through a solar filter. But yet, when I did this observation on the equinox, as flat earthers told me to do it on the equinox, do it
Yeah,
on the equinox, do it on the equinox, and then use a Nikon P1000, the only camera that doesn't make CGI for some reason, we see no discernible change in size, none whatsoever. So if it was very apparent to the naked eye, but it's not apparent to a solar filtered camera, then clearly something is amiss here. Maybe, just maybe, throwing this out there, it's the glare that you're looking at, not the solar face of the sun itself. Is that at least an acceptable explanation for what may be going on here?
yeah, it's acceptable. I mean, like I said, until I test it for myself, I'm not going to assume either way. I'm a heavy lean right now that it isn't, but I can't say for 100% certainty, and I don't like to do that. I don't think you like to either.
Then what we're going to do is I'm going to save one of these questions for later because I do want to get to it, but I do want to highlight it
Go for
here. Uh, Icy Spin for $1.99. Thank you so much. If the sun is small and local, why colder at higher elevations? I'm going to get back to that in a moment. So we're going to hold that thought. For the next
Yeah,
one,
I was saving that one for later. This is the one I was about to get your attention for.
yes, Ted for $4.99 says, Geo, um, did any of those videos you saw of the sun look anything like the one Red showed you? Be honest, because they look completely different to me. I'm going to ask Ted to also clarify this question because I think he's asking, did they take the same precautions that I took when I did my observation? I think that's what's being asked here.
Well, I can't say if they took the same precautions or not. Maybe they did. Most of the videos that I saw, or a lot of them, were either pictures taken, say, every 15 minutes, or time lapse of some kind. If that
Were they
answers your
zoomed
question.
in?
I'm sorry.
Were they zoomed into the sun so that the sun was a very dominant feature within the frame? Like, for example, I think I had well over half the frame occupied by the sun. Was that the case with any of the videos that you saw, or was it completely zoomed out? And
Some were and some weren't, but the majority, I would say, they were, yeah, they were not zoomed in, or at least
so they
not
were
zoomed
not.
in very close.
Okay. Now, this is something that I would like people to understand. Even through a solar filter, you can be susceptible to glare. The way that you get around that is through two different ways, especially with the Nikon P1000. When you zoom in, it auto adjusts the exposure correctly. So zooming in will set the exposure for you. But if you're zoomed out, since the camera is not telepathic and it doesn't really know what it's looking at, you need to set the exposure correctly manually. There is a way to do that. What I see happen all the time is that flat earthers are continuously and constantly looking at glare rather than the solar face itself, the actual true angular size of the sun. If that is the case, then the only way to solve that issue would be to take my example, zoom into it, with a solar filter and record it all day long like I did. I have my equipment listed in the description of that video, I believe. If not, I'll add it. But have you seen any flat earther zoom in on the sun with a solar filter or track it all day long like I did? What did they do that was, or you know what? Scratch all those questions. Did they do anything that was better than my methodology? Let's just ask that. Did they do anything that was better than my methodology?
Well, none of them really talked about their methodology. So I can't say that they did or they didn't. Maybe they did not, but maybe they did. But like as they're presenting their evidence or their side, they're not saying, "Well, I'm using this camera with a filter." Blah blah. I don't think I've ever heard that. So you may have a point, but we don't know for sure. And cameras are not my expertise at all. So I'm going to have to take your word for it until I can do it myself. And I don't know.
That's what I recommend. I recommend doing it yourself. I mean, I list all the equipment that I used.
Sure.
But here's the thing, you don't even have to track it all day long like I did. You can go out in the morning, like 8, 9 in the morning, whatever, take a picture of it at max zoom, then take another picture of the sun at noon at max zoom, and you can compare the two images and see that there's no change between the two. The amount of sun in the frame will be equivalent to the one you took previously. See what I mean?
I think I see what you mean, but I'd have to do it myself. I mean, we all would have to do that for ourselves.
All right. Well, then let's talk about another thing. But first, I got to show this super chat. For $10, I might be mispronouncing this, so I apologize. Lael, I believe is how you pronounce that.
Yeah, it's Lael.
So this argument is valid because I have never personally been to the Great Wall of China, verify the wall exists. However, the millions of pictures verify that the wall exists beyond any refutation for $10. So yeah, basically don't shoot the messenger on this one. A lot of people have done angular size measurements, and those that have done it properly have seen no discernible change in size. None whatsoever. And that is what is predicted by the flat earth model. Being that we do not see that, I think it's safe to say that there is indeed a contradiction with the flat earth model. The flat earth model predicts an amount, and I can actually show you this here. Let me go ahead and bring this up. Okay, here we go. So this looks like a bunch of gibberish and garbage. It's a lot of math, I know, but let me just explain it very simply. This is a prediction. What would we predict to see on the round Earth model? On the round Earth model, we would expect the sun to remain the exact same size by 99.995% the same size, meaning any change that would be on the angular size of the sun, it would not be discernible to us here on Earth. It just wouldn't be. On the flat Earth model, I had Slice Barcane make this animation. Now, this camera is placed on my latitude in Florida, and the sun has a diameter of 65 kilometers, and we're placing the sun about 5,000 kilometers up, okay? Now, what we're going to do is we're going to look at the view from this particular camera as the sun goes through its, let's call it an orbit. So there's the view right here. So see how the sun is growing in frame? So there's solar noon. Now watch between solar noon and sunset. That's what we would expect to see. There's sunset. That is an extreme change in angular size. That is what is predicted by the flat Earth model. And this one, the reason why we did it this way is because there's no math involved. You can just look at it and see it and know this is what is supposed to be happening.
Can I ask a question? What's the green cube supposed to represent?
The green cube is just the control surface for the camera itself. So the green cube can, because it's a program. That's just how the program works.
It's spinning as well as the Earth is spinning, the sun rather.
No, it's rotating the camera to
It's
follow the
rotating.
sun.
It's rotating the camera.
Yeah, it's rotating. Yeah, this cube only rotates the camera. This is a control surface. Imagine these lines of the cube as handles to the camera. And the
Okay.
computer program is turning the cube, which turns the camera, which allows it to follow the sun in this model.
Should the red circle that the sun is rather than well, how do I say this?
Well, the red circle right here represents the equator. This represents the equator. So the sun would be traveling over this circle on the equinox. And when I did my observation, I did it on the equinox.
Okay.
So in order to make sure the prediction matched reality, I needed to predict what would happen to the angular size of the sun on the equinox and then actually do my observation on the equinox.
Now, another thing that maybe I don't think I mentioned for the flat Earth model is that the flat earthers believe that the sun travels between the Tropic of Cancer and Tropic of Capricorn.
Correct. But on
Okay.
the
So,
equinox, it travels over the equator.
yeah, but given that, how would I say this? There's quite a distance between the two tropics. There would be a probable noticeable difference in size.
Well,
With the local sun.
you would be wrong there. There actually isn't that big of a difference, and especially not one that we would be looking for throughout the day. So throughout the day, the angular size between sunrise and solar noon should change by a factor of 2. That's the value. If we were to look at the flat Earth model between the difference between the Tropic of Cancer, Tropic of Capricorn, or whatever, the change would not be by a factor of 2. So the daily shift in angular size would be much greater than the yearly shift in angular size on the same time of day or during the same time of day.
Now, again, are you taking taking a large sun that's far away from us? Is that what you're using as part of your equation?
Nope. What's happening here on the flat Earth model, we put it. We have 2 parameters. The sun is 165 kilometers across, and the second parameter is that it's 5,000 kilometers in altitude. Now, I'm going to give you a little bit of a insider information here. The flat Earth conspiracy puts the sun at many different altitudes. Some say it's 3,000 miles up. Some people say it's 10,000 miles up. Some people say it's 7,000 miles up or whatever. It actually doesn't matter where you place the sun over the flat Earth model, because the values that flat earthers want to go with are not in the millions of miles. Because they're within the thousands of miles, we would expect to see some shift in angular size throughout the day. The mere fact that we don't shows that there is a contradiction with the flat Earth model. That contradiction needs to be answered for by flat earthers, and it hasn't yet.
Okay, hasn't yet, but this is the first time this has been presented to me. Send me some kind of link, and I'll be happy to do some research into it. Now, if I may, you've asked 3 questions in a row. Can I ask a question?
Sure. Before you do, I'm not going to ask you this question, but Ted is. Ted for $1.99 says, Geo, do solar filter images look different to you? Just answer that question real quick, and then we'll move on to your questions.
Well, again, I'm not a camera expert, so I can't really comment on that.
Understood.
I don't know. I'm not a camera guy.
Okay, that's fair. But if you, what I would recommend then for Ted's benefit is to do yourself.
I can rephrase that question as it is a simple yes or no question, and it was alluded to earlier as well.
Go ahead.
Geo, the videos that you had referenced before, referencing the size of the sun changing, from just a purely visual standpoint, does the video that Red presented to you earlier on the stream, does that look different, significantly different than the videos that you had seen previously that align with your stated beliefs?
It does look different, and one of the main differences is that in the videos that I've seen, or many of them, as they've watched the sun track all the way over the horizon, not only does the sun get smaller, but the light from the sun follows the sun. And there's no what's it called? A terminator line? There's no terminator line. It's almost like you'd expect the entire horizon to get dark at exactly the same, but that doesn't happen. The light that's following the sun as it's really small and far away is centralized to where the sun is. So that's the two differences between Red's pictures and the ones that I've seen, if that answers your question.
A bit more clarification and follow on. So would you say that the imagery that you're referencing look more akin to, hey, Red, so in this video clip that you have up, go towards the end when you take the filter off.
Okay. Let me go. So here's...
So you would say that the imagery that you're referencing has more of a visual appearance of this as opposed to the full shot
so here's
that Red was at before?
Yeah, so here's the solar filter, and let me just try to time it right. So solar filter still, now no solar filter. So this was as the sun was just going over the horizon.
Yeah, most of the pictures that I've seen, at least, have the sun a lot smaller than that.
But just purely visual, does it look more like this, or when Red's had the solar filter on? Just from like a color and other items that you may see in the view.
It looks more like this, but what I'm trying to get across is that as the sun gets smaller and smaller and further away, as it disappears over our perspective, the light also follows it that way, as if it was a small local sun. There's no terminator line, as you've probably seen in some science fiction movies, where all of a sudden nighttime is going over the land in almost a straight line. There's none of that. So
all right, I'm gonna ask Jared to also keep a really sharp eye on that first super chat that we had about altitude. Just hold on to that. We're also going to thank you. Just remind me so I don't forget that, because I do want to get back to that later on. But Gio, we did bombard you with a bunch of questions. I agree there. So I'm going to go ahead and give you the floor. What are your questions?
Well, okay. One of the things that we see every day of our lives is that it turns into night, obviously. It's like when you walk into when you turn the switch on in a room, say in your kitchen, the light engulfs you. Not only is the front of you that is facing the light lit up, but behind you as well. On the globe model, as the Earth rotates away from being in front, where we are, and now we're in the night. Why do we experience night if the sun is this big light emitting light equally because it's round? Does the light finish exactly where the Earth is? You know what I mean? Like if you're in a room that's lit up, everything is lit. We should never even see darkness in the sky at night, because we should be engulfed in the light of the sun. And according to NASA, they have pictures of Mars where it's daylight, and Mars is significantly farther away from the sun. Now, if Mars is in daylight, well, the entire Earth should be in daylight, but we have night. Can you see where I'm going with this?
It's called reflection. In a small room, light is bouncing.
No. When you, like I said, walk into a room, turn the light on, the whole room is engulfed in light.
Because the whole room has the capability of scattering light. Now, if I'm in a room, which I am in right now, my walls are painted white, which means they're going to reflect a shit ton of light. Now, if I were to paint my entire room in Fanta black, which absorbs 99.99 some ridiculous percentage amount of light, then I'm not going to get the entire room lit up. There's going to be really prominent shadows on the quote unquote dark side of certain objects that are within my room. But because my room has the ability to scatter and reflect light, then the entire room is going to appear lit. Whether it's, that side of the room, this side of the room, whatever, it has the ability to scatter light. Now, in space, there is no wall stopping the light from bouncing off. There are a few planets, and that's why they appear to be lit in the night sky, because they are there to reflect the light back from the sun back towards us on the dark side of the Earth. However, that's it. There is no wall for light to be scattering to illuminate the dark side of the Earth. That's why it is dark.
Red, I think you're making this up as you go along, buddy.
You wanna bet? Because guess what? There is actually a guy that painted his room in Fanta Black. There is a guy.
No. We have pictures on Mars where the entire sky is lit up, according to their photos.
Who is they?
NASA. Sorry. NASA has apparently sent probes to Mars, and the pictures show the entire sky is lit. It's in light. And you're saying that
during the daytime it would be.
Yeah, in the daytime it would be, but if it's lit up by the light of the sun and Mars is further away, well, we shouldn't have night. We should be inside the light of the sun, is what I'm saying.
The only way that we're going to get light from the sun is if the light has a path to us. If the light doesn't have a path to us, then there will be no light.
So what's the path, this magical path that you're saying is because we have an atmosphere?
Well, atmosphere does help scatter a little bit of light. That's why you'll see the glow of sunrise before the sun itself comes up. But yes, scattering does play a role in that. But when you go beyond what scattering can realistically do, then there's no direct path for light to hit your eyes or your surrounding environment or whatever. That's why we have night. The reason why we can see Mars in the night sky is because it is reflecting light back towards us. And guess what? Mars experiences night just like we do here. Jupiter experiences night just like we do here. And the same is true for, our moon. Our moon has a night and day cycle. There's no difference. The same way that it works with them,
I'm not satisfied with
us.
your explanation. I'm not. Maybe everyone else is, but I don't think it quite works that way.
You would need an actual. Okay, let me just put it to you this way: if you were to put a light in a small room, you would be able to illuminate every portion of that room, correct?
Well, if it's a small light, not quite all of it, but how big is the light?
Let's say it's a light bulb, and let's say the room is 6 feet by 6 feet. If I had a light bulb in that room, it's 6 feet by 6 feet. I should be able to illuminate every portion of that room.
Probably, yeah.
Okay, probably. So this video right here shows that you're wrong. And the reason you're wrong is because he is in a dark room and he painted it with the blackest paint. This paint is similar to Fanta Black. I don't think he actually used Fanta Black in this case, but the reason is because it is absorbing light. The light does not have the ability to scatter when it's actively being absorbed. And so he's going to have dark sides of him. Like, for example, I doubt his arm is this skinny in reality. Half his arm is missing. What the hell? Whoa, this arm is in darkness. This arm right here is in darkness. There is a definitive dark spot there. That is the same principle, the same thing that's happening when it comes to the planet. Eventually, we rotate out of a path that light can reasonably take to get to that part of the planet, and therefore we have nightfall. But if you're in a room or if you have a surrounding, object around you that can reflect light back, then you will get, and you can see, this is the room. This is the room. As you can see, this is the room. It's not big at all. And this was the light. See? Now he has something scattering the light, and you can actually see a little bit more. But when that's gone, you can't see as much. Light needs a path. Light needs the ability to reflect off of something. If you don't give light that path, then light can't get to where it can't get to. It's fairly straightforward. And this was the room as he was painting it. Now you can see, look how visible everything is. Look at you can clearly see the corners and the wall and everything like that. You can see everything so clearly in this. But when it's actually painted Fanta black, or close to it at least, now look at it. Now it's a lot darker.
Couple of problems I see with this. The gentleman in the picture is a lot larger relative to light than Earth and Mars are relative to the sun. I don't think that's quite a fair comparison.
We're talking about a single thing, though. We're just talking about a single thing, and that is light having the ability to scatter.
The parameters are different. Like we're talking about something that is, 93 million miles away. This guy is probably 2 feet away from the light. And he's much bigger than the light. We are a small little dot compared to the sun, which is significantly further away. I just don't understand why you would think that this is a very good comparison. I see the basic idea of what you're sure. Light will dissipate after a while. I don't know how we see the stars that are supposed to be trillions of miles away, but I don't think this is a fair comparison for the size of the Earth relative to the sun, the distance, and all of those are different parameters.
How is size going to be relevant here?
Well,
you're talking about the path of light, and
the path of a small little light compared to the gigantic sun. I can see the idea of light dissipating because I get that, but I just don't think
this tiny little light was able, quite easily, I should say, to illuminate this entire room, to illuminate this person, where I could see the entirety of his arm. I could see the entirety of his torso, leg, and whatever. Mm-hmm. But as you can see, he's painting this room a really, really dark black, a color that is going to absorb light. This tiny light had the capability of doing this previously. We are changing only one thing about this setup. That one thing is the color of the room and the light absorption properties of that room. And when you do that, you get, this. It's a dramatic difference.
Well, if you put that same light in a room that was 100 feet by 100, it wouldn't, and the walls were even white, it wouldn't light the whole thing up.
Probably, but we're talking about a room that's only 6 by 6, 10 by 10 at most. It's to the point where the idea is that it's a very simple idea. Light can only get where light has a path to get. If light doesn't have that path, if it gets absorbed midway through, it ain't going to reach its destination, which in this context would be the dark side of the planet. That's why we have light and day. That's my final answer. If you don't understand it, I'm sorry, but we're going to have to move on to the next.
I understand your premise, but I don't agree with it.
Okay, what's your next question then?
Okay. The moon is supposed to be orbiting around the Earth, as we're orbiting around the sun.
Yeah.
You probably know where I'm going with this, right?
Not a clue.
Okay. How is it that the moon always stays the same distance from the Earth?
It doesn't.
Whether the moon is in front of the Earth or behind the Earth, does the moon speed up and slow down?
The moon is orbiting the Earth.
Right.
So, and also I understand this might be nitpicking, but the moon actually does recede from the Earth. What was the rate? 4 centimeters a year or some shit like that? I'm not exactly sure. I'll have to look that up, but it's a very, very small amount. But just so that people don't harp on me later on for not being super accurate about this, it does move away from the Earth very slowly, but it does happen.
Well,
But
that's not what I'm saying.
I know,
The-
I know, I know. I'm just doing that for the
Right.
people
Okay.
who
Okay.
might try to shit on me later.
Fair enough.
But as far as the Earth and everything, the Earth Moon system is just that, a system. The Earth is a gravitationally dominant body in that system. The moon is going to orbit that system, excluding all other things. That orbit is going to be consistent because there's no external force that would cause it to slow down or speed up. That momentum is conserved. Follow me so far?
I follow you. I just don't agree with it.
Okay, well,
If the Earth is able to keep the moon perfectly in orbit like that, it would have sucked it in by now.
no, it's not. No, absolutely not. Do you know how, like, why would the moon be sucked into Earth?
Maybe you're not following what I'm saying.
No, that's why I'm asking the clarifying question. Why
Well,
would the moon be sucked into Earth?
for the Earth to be in front of the moon as it's orbiting the sun, the moon is stuck to the Earth because the Earth's pull is so strong. Is that what you're saying? And it doesn't matter whether the moon is to the right of the Earth, to the left, or in front. The
Yeah, it's
you're
almost
saying,
as if gravity is omnidirectional.
well, we've never really proven gravity, but that's another thing.
I think we have, being that I can use the formulas for gravity to make accurate and precise predictions, and at the end of the day, that's all that matters in science. Does the model work? The model works. We have a person in the live chat called Astronomy Live. He uses these formulas to actively predict orbits. And if he can get really, really accurate results to the point where he points his telescope at a part of the sky where something is predicted to be and it ends up being there, then yeah, that shows that we have a pretty damn good understanding of gravity.
Well, again, I'm going to disagree with your answer. I don't think that the Earth is perfectly in pulling the moon at all times, no matter where it is, without the moon flying away from our orbit or being sucked in. I guess you have more faith in that than I do.
It's not about faith. It's all
Well,
about understanding that an
well, no,
equilibrium exists.
you're saying it's about understanding. I don't think you have an understanding of it. Maybe I don't, but
I'm gonna make
getting-
an assertion here that you definitely don't. So let me.
Well,
anyway,
getting-
you should go ahead with the question.
Hang on, guys, because getting to that, there is a relevant question from the chat that has actually been posted effectively twice now by Milbrat Set, which he's asking you, Geo, are you familiar with what a supermoon is and what actually causes it?
Yeah, I've heard the supermoon many times. It appears to be closer to or it is closer to the Earth. Sometimes it is other.
Okay. I'm kind of glad you said that because now I have to jump to a different question.
I didn't
from a
realize I
fellow
was debating.
moderator.
Okay.
I'm bringing questions from the chat.
Okay.
And
Sure.
I'm glad
thought that
you
was later.
kicked to open that door.
I
Well,
thought that
no,
was
it was relevant as they're coming up through that way. Audience participation. It's a wonderful thing. But you were just saying earlier that the moon, according to the globe model, does not change distance, and yet in your answer there,
No.
you admitted that it does change
No.
distance.
That's not quite what it
So,
said.
are you a genuine believer of flat Earth or not?
Yeah, that's not quite what I said. What I said was that as the Earth apparently is orbiting the sun and the moon is orbiting the Earth, that the moon would have to stay in perfect orbit with Earth, seemingly slow down and speed up relative to the Earth. That's what I said.
Well, this is why I asked about that systems thing. Now, you're just going to have to work with me here.
Okay.
I want to try and answer this question for you, but it takes us going in steps, and I think that's fair. So, step one, Ignore the sun. Ignore the other planets. Ignore the rest of the universe. Just ignore the rest of the universe. Let's have just the Earth and just the moon. The moon can orbit the Earth. Let's say that it's just the Earth, just the moon. The moon can orbit the Earth, all things being equal, correct?
Okay, and with your model?
Yes. Again, we're taking this in steps. The Earth-Moon system is the only thing in existence. The moon can orbit the Earth, correct?
Oh, well, okay, I'm going to go along with you, sure.
Okay. The moon can orbit the Earth. Now let's say that entire system is in motion in any direction, not towards something or away from something or tangent to something, just moving in general, the whole system. Does that system get disrupted when the whole thing is moving in unison?
Well, I would say no.
Yeah, exactly. So no. So we wouldn't say in that context that the moon is speeding up or slowing down depending on where it is in its orbit. We would say that the whole system is just in motion and it still makes perfect sense. Now, put that entire system in orbit around a much bigger body like the sun. And there you go. Everything still fits. Everything still works.
No, because you're adding another factor in. You're saying that not only is the moon rotating or orbiting the Earth, but both objects are orbiting the sun. And don't forget, your model says that the sun is actually traveling through the galaxy. So there's another
very, very
this is a
slowly.
third. I'm sorry.
It'll take over 100,000 years for us to make a single path. Again, we like to claim, or flat earthers like to claim, that the speeds are so extreme, while only saying that they're extreme on a human scale. In terms of the universe, it's slow. Even the speed of light is slow. It takes 4 years for light to get to the nearest star, and there's billions of stars in just our one galaxy.
Again, you're assuming that that's what the stars are. I don't prescribe to that. I believe that
that's fine that you don't prescribe to it, but I'm talking about if we're looking at scales here. Again, just looking at scales. Our scale shows that that's not fast. And
right, your scale does. You're right.
Physics
I believe
agrees with us. That's the point.
Your model says that the universe is billions of years old, which it may be, but that the sun is this big. My model doesn't comport with that.
Yeah, so, but your model doesn't comport with reality. That's why I asked the question at the beginning of the
I have a different
debate.
view of it. I believe that our system is a lot different from your system. So when you say that compared to the size of the universe, we're minuscule, yeah, in your model, but that's not what I believe, and I don't think any flat earther believes that. So,
but if you're asking a question about my model, then you have to go along with the step-by-step understandings with it. And
no, I understand how your model works.
Then you will have to agree that all things being equal in my model, being that we have an understanding of gravity, we have an understanding of orbits, we have the mathematics needed to make accurate and precise predictions that allows us to make these astronomical observations in the first place, it all works. You don't have to agree that it's actually the case, but in terms of a mechanism in which it would work, we have that, whether you understand it or not.
Well, yeah, like I said, it's your model, and somebody else's model might be that we were all seated by the zucchini people, and they would feel that that's correct too. But
yeah, but only one of us would have evidence and the ability to make predictions, and that's the difference.
Well, there's observation.
I would like to ask what the third question is, because that was 2, if I remember correctly.
Yeah, no, I you can ask a question. I don't want to hog the entire time.
All right. Well, then in that case, I would like to bring up a previous super chat. Let's go ahead and just take this out. So Tim for $10, and thank you very much. Go out to the country to a cornfield with no trees or nothing in the distance for lights to reflect other than the ground. Is the dark sky lit up? No, it isn't. I guess he's trying to make the reflection argument thing that I was bringing up previously, but I did want to show that because I like to try and show the super chats. I apologize for missing that previously, Tim. That was entirely my bad. So the next thing that I'm going to show is going to be a screenshot from my previous debate with Jeranism. And what I would like to show here is a model, a virtual model. So let me full screen this. There we go. Okay, so Gio, this is a model of the Lake Pontchartrain Causeway. This is a virtual model about what we would expect to see on a round Earth, given a clear enough day. So as you can see, as the bridge goes further and further away from the observer that is at this particular height, you can see that it curves down. And these huts that are on the side, I guess they're maintenance boxes for, well, maintenance. But as you can see, as the bridge gets further and further away, the curve becomes more and more pronounced until Bob's your uncle, it actually starts disappearing over the horizon. This is what was predicted by the round Earth model. Now, this is the part where I show this portion or this image. You can see it matches. There are the huts on the side, and as he gets further and further away, the curve shows itself. It's exactly what was predicted by the round Earth model. So my question to you is this: given that the round Earth model made a prediction and that prediction turned out to actually be the case, does that not score a point for you when it comes to the round Earth model?
Well, the model is very pretty. I'll tell you that much. I don't know about scoring a point. It looks like it's curving at as if the Earth was really small.
Well, keep in mind, we're zoomed in a lot here. So we got to keep in mind compressed perspective here. This bridge is like, what, 25, 30 miles long?
Okay.
So what you're seeing here is a lot of bridge, a lot of bridge. And when you look at this bridge in totality, the curve becomes obvious. And keep in mind, we modeled that on a Earth with a circumference of 40,000 kilometers, which is the accepted value. That's what was predicted in that model. So clearly, we're looking at a model of the Earth that is the size that the nameless, faceless they say it is, and reality agrees with that prediction. See what I mean?
Okay, two things I want to. You say it's 20 kilometers long?
Not 20 kilometers. I forget the exact distance of this bridge, but it's tens of miles.
Okay, it's tens of miles according to the.
It's the Lake Pontchartrain Causeway in Louisiana.
According to the formula for determining the curvature of the Earth and how much it should dip over the horizon, that probably the end of that, it should be underneath the horizon. We shouldn't even see it at all if the Earth was curved. And
we don't see the end of it. We don't see the end of it.
Right.
That's
well,
the point.
If you were to get on a flat street and a road and watch as somebody walks away, within about half a kilometer, you wouldn't even see their legs anymore. You'd only see their, because of perspective. Now, my second point is, do you have a picture of that as you're to compare as you're zooming in with that nice camera of yours? Like if you took your camera and zoomed in from that same perspective where this picture was taken, would it appear to do that as well?
I'm pretty sure. Now, I haven't done this image myself. This is actually an image that was captured by a user by name of Soundly, so credit to Soundly there. But he had this image virtually modeled on an Earth with a circumference of 40,000 kilometers. He modeled this bridge, said, if I zoom in this much and I'm at this height and I'm pointing at the bridge, what should I see? This is what the model showed. This is what you would see on that model. Well, when it's done in reality, That's exactly what you see. You see that curve. It matches beautifully. So not only is the model beautiful, which I would agree, it's beautiful for a very specific reason. And that is it has the ability to make accurate and reliable predictions. That prediction turned out to actually that prediction turned out to actually be the case.
I think
So
what it's predicting is that it is predicting what we will see given the law of perspective.
what is the law of perspective to you?
Well, things get smaller, and they converge upon each other. You've been in a long hallway in an apartment building where the light fixtures are the same, but they seem to get smaller, and the further away that you get, and they actually sort of at one point they it feels like they're at the ground level. This is what perspective is. We don't. What I'm saying is, if you could show me this picture side by side with you zooming in with your nice camera, it would be better proof. This just shows that what we see day to day, every day of our lives, that things get smaller and they hit towards the ground. It
Yeah,
doesn't show anything else. It's a model.
but
I used to make models when I was a kid. Doesn't
but
prove anything.
angular size doesn't dictate that it will start to disappear bottom up and then eventually out of sight, nor does the law of perspective state that objects are going to start curving, especially with a straight and level bridge. The law of perspective is a mathematical equation. That equation does not state at all, period, in any way, shape, or form that this bridge should start bending.
Well, you give me, like I said, you give me a side by side with your nice camera. It would be better, more compelling evidence, at least. I don't.
So we see a prediction of a model. We see that prediction turn out to actually be the case, and this is not good enough evidence for you.
No, I don't think it's very good evidence, Red. I'm sorry. It's
Okay.
predicting a model. You know what? You want to impress me? Predict the winning lottery numbers. I'd be very impressed. Anyway,
I don't
I'm
think
kidding.
the winning lottery numbers have anything to do with
I'm kidding.
geometry.
I'm kidding.
So Siggy for $20 says, RR, here's a model done using what science says. Here's a picture that shows in reality what we expect to see if the earth is round. Flurf, reality is wrong. Here's a bunch of words that refer to things I don't understand. Damn, Ziggy, tell us how you really feel.
See, this is the worst part of the globe Earth flat Earth thing is and we should all be trying to figure this out together, and the nonsense that goes back and forth is really off-putting.
All right, so do you have a question, or can I get to the next one that I have?
Gee, what was my next question? So okay, if the Earth is rotating, then an object dropped from, say, the beginning of the atmosphere, it should fall straight down, or should there be the rotation of the Earth should make it? Let me get back to expound on this. When in my research, I was looking at that Felix Baumgartner jump. You're familiar with it?
The Red Bull Stratos?
The Red Bull, that's correct. Now, for 2.5 hours, this guy goes up in like this 55-foot tall balloon. For 2.5 hours, he's ascending, and then he jumps. For about 4 minutes, he free falls, and then he pulls his parachute. So you can see as he's gliding down that he's sort of going on a bit of an angle. We've all seen balloons up in the air and how they drift with the wind. And so he's up there for 2.5 hours plus the time that he's falling, and he only falls about 23 miles from where he actually left in Roswell, New Mexico, of all places. And when he falls, he only fell 23 miles from that. Now, given the fact that he's up in the air for 2.5 hours and then he's gliding on an angle, don't you think if the Earth was spinning, don't you think he'd land somewhere in the Pacific Ocean?
No. Why should he?
Well, because the Earth is rotating, and he was I think 40 kilometers up. That's 40% of the distance to the, and I can't remember what it's called, 100 kilometers up where the space is supposed to start. He was 40% of the way up there, and yet
let's take this step by step. I'm going to talk about something that will sound irrelevant and not applicable at all, but I just need you to trust me on this and just work with me on it, okay?
Okay.
If I were to drive on a perfectly straight road between the East Coast and the West Coast of the United States, I did the same exact speed. I made the same number of stops. I did the exact same thing in both directions. I would get to each coast in the same amount of time, no matter which direction I started from. Is that correct?
Correct.
Okay. Now, the reason that is because the ground, or I should say the road, has a 1-to-1 speed ratio with the rotation of the earth. The ground is the medium in which I am traveling. The atmosphere also has not a perfect ratio, but a pretty damn close, at least close enough for our purposes, a 1-to-1 speed ratio with the ground. The balloon launched is within that medium. That medium is moving with the Earth. So as the Earth rotates, so does the medium. If the medium rotates, it takes the balloon with it. So that means that if the ground and the atmosphere have a damn close 1-to-1 speed ratio with each other, then we should not expect him to land 1,000 miles away, because in order to get that far, he would have to be moving against that medium, which would require external propulsion, which, if we remember from the Red Bull Stratos launch, he didn't have that.
Yeah, he didn't have that. That's right. So
Correct. So therefore, he wouldn't have landed in the Pacific or Atlantic or wherever the fuck.
So you're saying then, if at 100 kilometers up, that's I forget the name of the word that it's used. It's the marcation where they say space starts.
The Kármán line.
Kármán line. Thank you. So at 100 kilometers above, there would be, but at 99.99, there wouldn't be, because he'd still be exactly in the, because he's 40% of the way to the Kármán line.
Keep in mind,
You're
he was still in atmosphere, and in order for that velocity to be canceled out, some external force has to do that work. There was none. He didn't have a jet engine or a rocket engine or any sort of engine for that matter. He was just riding that balloon all the way up, which was at the mercy of the atmosphere and the wind direction, stuff like that. If the atmosphere, for the most part, again, not perfectly because it's fluid, but for the most part has a 1-to-1 speed ratio with the ground, we should not expect to see any significant distances gained via balloons.
Well, again, so if he made it to 100,000 kilometers, you're saying it wouldn't be 1-to-1 anymore.
It would be 1-to-1 close enough. I'm saying it's not perfect, but it's not the extreme speeds that would be needed in order to make it from Roswell to the Atlantic Ocean. It just doesn't work like that. If we are within a medium that has a 1-to-1 speed ratio with the ground, then we are subject to that principle. We cannot operate against that principle unless we did the work. In order to do the work, you would need a jet engine or some sort of engine, a fucking propeller maybe. But he didn't have that. He didn't have an engine or a propeller or anything like that. Therefore, we were at the mercy of that principle.
That's an unsatisfying answer, but we'll move along. Go ahead, ask a question then.
Cool. Anyway, so for $50, Siggy, thank you so much for your super chat. I appreciate it. Dear Flat Earthers, or Earther, with all due respect for the humanity in you, this has already been figured out and tested in so many ways that there's no need to debate it. Take a physics class in community college, learn the science, come back to talk about it. So I think Siggy is trying to be a little bit nicer in this one, but I can still see he's a little bit frustrated. And Siggy, I just want you to know, it's okay, bro. It's okay.
I remember, Siggy, that in my years and years of researching the flat Earth, I've many of the answers that Red has given me so far, I've never heard of before, including this last one. this 1-to-1 ratio. I would have come across that, and I would have said, well, I want to ask that question. Maybe that's it's a plausible explanation, Red. I'll say that it's plausible, but I don't think it works that way. But I will give you some plausibility.
I'll take the plausibility as it comes. So
you have to be honest. You have to say, okay, that could make sense. I've never come across that, and maybe it's just a coincidence.
I'm so thankful for the answer and response from you, because that feeds perfectly into a couple of questions that I'm going to merge into one from the audience. It has been brought up before about evidence. What is your standard of evidence? But also, very, very pointedly, this one has been brought up. Gio, if you are going to constantly reference you needing to do it yourself to believe it when Reds provide something, what verification have you performed against the videos that are in favor of flat Earth?
Whatever I am able to do. I mean, if there
examples, please, not a vague answer. You have stated that you need to test this stuff to verify it when it's coming from Reds. What verification have you performed against the videos that are in favor of flat Earth?
Like pure scientific tests? None.
What work have you done?
What work? I'm sorry. Are you saying the word work?
Yes. What actual actions have you taken to verify and confirm that what people are telling you in these flat Earth videos is actually the case?
Well,
since that's the standard that you want to put Reds to,
no.
Do you hold yourself to the same standard?
Look, it's hard to come up with a very concise rebuttal when I'm being presented something and I'm on, and I think Red would do the same thing, say the same thing. This is why the idea of presenting didn't really work for me. But anyways,
if you need to admit that you haven't done any verification, that would be a much more honest answer at this point.
Okay, well, my verification is mostly observation, and observation is the foundation of the scientific method. If you can see it, if you can experience it, if you can measure it, I've looked out windows of airplanes and noticed that the Earth is flat. I've walked outside and noticed that nothing moves. I don't have to take a picture of something necessarily. And I also try to make sure that I read both sides of the argument so that I have a better understanding. So, I mean, as far as scientific tests, I haven't done any.
Let's look at a single test. Let's look at a single test. But first, I'm going to do this. I believe this is a question that kind of fits in here. So the question is, since Gio has been studying flat Earth for years, give one piece of positive evidence for flatopia. Let's just call it flat Earth. Give one piece of positive evidence for flat Earth, as in what observation have you done, or maybe not that, could be done. There you go. What observation could be done that confirms flat Earth?
Well, all you have to do is look at Polaris. You knew Polaris would come up. And every year, every decade, every century, every millennia, you go back to the Babylonians, the Egyptians, they've been studying astronomy. And yes, according to your theory, the stars are trillions and trillions and trillions of away. But we can see through observation that every year the stars are the same. If we were spinning around on an axis around the sun, through the galaxy, through the universe, the stars would change every night.
They do move. I'm sorry that astronomical things don't conform to human lifetimes, but that doesn't mean that they don't move.
I'm not saying you would see your name written in the sky one night and then my name. No, but there would be measurable differences. But
there are measurable differences. The measurements are very
difference.
No, there are measurable differences. The differences are very subtle and difficult to measure, but notice the use of the word difficult and not the word impossible. They happen.
Well, then
And
there again, that will prove or disprove any argument.
okay, let's observe the night sky then. Let's observe the night sky together. So we're going to go on a journey to observe the night sky. I would like for you to answer one question about this particular video right here. I'm going to play it, and we are going to take a look here. Oh,
I didn't
hang on.
think we were going to be presenting any video or pictures, by the way, which is fine.
That's what I do when I show up to one of these things. I'm ready to rock and roll. Anyway,
Okay. Good for you.
so can you see that? See how the telescope's moving?
Yeah.
Okay, I'm going to play that one more time. This is what he was imaging. This is footage from Astronomy Live. And as you can see, in order to take that picture, notice how the telescope is only moving one axis. It's not pivoting here at all. It's pivoting down here at its base. See that?
Yep.
It's only moving one axis of rotation. Now, let's go ahead and go to an actual model. So what we're going to do is we are going to have a flat Earth model with an object rotating overhead. What does the telescope have to do in order to follow that object? Well, I'm seeing that telescope on the flat Earth has to rotate two axes of rotation. Here's declination, and here's right ascension. So on the flat Earth model, it has to rotate two axes in order to follow a celestial object. Now, what about the globe? Let's go ahead and check out the globe right here. So on a globe, let's go ahead and let me fast forward here. Oh, there it is. So there's the globe model that we're going to use. The observers in Florida, as it was when Astronomy Live was doing his observation. And as you can see, there's declination, not moving whatsoever. And there's right ascension, moving as it should. So in reality, we only have to move one axis of rotation in order to follow a celestial object. The model needed in order for that to be the case is the round Earth model. And when we apply that to a flat Earth model, we then have to rotate two axes in order for it to follow a celestial object, i.e., there is a contradiction within the flat Earth model. So, given that equatorial telescope mounts work, do you have an answer for the geometric impossibility of an equatorial telescope mount working on a flat Earth?
Well, I think you're assuming that all of the objects in the sky are going in a straight pattern, but they're not, because the stars are different distances in this night sky from Polaris. It's almost like they're curving, which we actually see when we do time-lapse photography.
If you were to look at a star trail time-lapse picture, you will notice that they form swirls, little circles. Those stars are not going in a straight line.
Right. That's
So
what I'm saying.
if those, and if you were to place an equatorial telescope mount on a flat Earth, and it were to go through an observation cycle from horizon to horizon, the line that it would draw in the sky would be a straight line. And yet the stars don't move in that way. But equatorial telescope mounts work in reality. And the only way to make them work in this model is to put them on a curved Earth. So why is there a contradiction?
I'm not following you. All I know is that I look up in the sky and I see the stars curving around the center star. Maybe it's me. Maybe I'm not following you. With my naked eye, you can see it through the night. If you were to focus on one star, it's circling. It's going in. It's going distance and arc. So it's going in two different directions. I can see that with my own eye. I don't. need a camera.
Okay.
Am I totally on the wrong trajectory here?
I would say so. Let's just look at this one more time.
What I see here, Red, are pictures and CGI, and a picture of a galaxy that's got a red gaseous ball, which, according to you, shouldn't be lit because there's no path of light, but there is now within this
Do you
galaxy
think
that
the
your friend
galaxies don't produce their own light? Because let me tell you something, they do. They're light sources.
No, but I'm saying they don't have a path of light.
What do you mean they don't have a path of light? We're looking right at them. Of course they would have a path of light.
Well, what we were looking at was a I don't know, CGI picture of a
Astronomical astrophotography images are not CGI. You're going to have to back that up. But before we get that far,
were you even told by them that they actually put the colors in themselves?
They don't put the colors in. My God. Okay. They have three separate channels. They have a red channel, they have a blue channel, and they have a green channel. Each channel is going to have a different amount of that particular channel, that particular wavelength. When you combine the two, or when you combine the three, you then get a full color image. That doesn't mean it's CGI.
Oh, well, what you're showing me are pictures and drawings, and I mean, I'll have to take your word for it.
These are models. They're
models. You're showing me models, which are very nice.
I'm not showing you this.
Verify them one way or the other in this conversation.
I'm not showing you these as an actual pictures. These are models. These are used to make predictions. What should we predict to see if this really is an accurate representation of reality? That is what's being shown here. If we were to put an equatorial telescope mount on the flat Earth, as you can see, 2 axes of rotation are needed. In reality, only 1 axis of rotation is needed. Therefore, the flat Earth model has a contradiction. What is hard to understand here?
You're like I said, you're just showing me cartoons and pictures.
Okay.
I want to get back to Polaris and say the Big Dipper. Okay, like the Big Dipper, Ursa Major has 7 major stars to it, right? Now, if you look according to NASA, these 7 stars are different distances to the Earth. Yet year after year, decade after decade, millennia after millennia, it's the same picture in the sky. I mean, given the fact that they're actually different distances from us, according to NASA, eventually, inevitably, inexorably, you would see over the course of millennia a different shape of the stars, but you don't. They've been talking about how Osiris has been like a map of the pyramids for thousands of years. Why are they consistently the same if these stars are not only far away, they're different distances away? There are clusters of nebula around the Big Dipper. I think one of them is called M61 or something, and it's like 1,000 light years away. The star that it's closest to is 90 light years away, and yet it's always there, no matter what time of the year, no matter which millennia we're in. Like the stars would have to look different over the course of time, but they don't. What's your explanation for that?
All right. Look at this outline. This outline fits pretty perfectly with this outline right here. They were once connected.
No, they're still connected. There's just water on top.
Which means these 2 giant land masses were connected, so they're moving. But yet, year after year, decade after decade, millennia after millennia, ships have to traverse this strait, and they travel the same distance all the time. But yet, the nameless, faceless they with the Illuminati and the lizard people are saying that they're moving.
They're still connected.
Just maybe, dude.
Water over part
maybe, just maybe, dude. The scales are such that it doesn't conform with a human lifetime or even several lifetimes.
Again, you're making a wrong assumption. They are
No,
still
it's not
connected.
an assumption.
They're
If the
still
stars
connected.
are moving slow and they're extremely far away, then you're not going to see a discernible shift over millennia.
Yeah, you
That's
will.
the way it
You
works.
will.
Scale
Uh,
is a thing. You can't ignore scale, say that it's all a conspiracy without providing any evidence to show that it was manufactured in some way,
well, I'm not
shape,
going to
or
live for
form.
millennia, so I can't. But right now, you can
If you
see.
can't do it, then it shouldn't be an argument. That's
Yeah.
the point. If you can't do it, it shouldn't be an argument. But if you're asking me why it is, and I have an explanation for it, you can't say that I'm wrong. The only thing you can say at best is that your answer isn't satisfactory, which
Well,
I
okay,
will accept,
fine,
but you
fine.
can't say I'm wrong.
Well, you can't say I'm wrong too. You can only say,
No,
"Am
I,
I
I
wrong?"
actually can because
Yeah, there you
unlike all the other flat earthers here, I actually have evidence. I can actually show you these things. I can show you parallax measurements. In fact, I can show you that we have made parallax measurements of distant stars. We know for a fact that Alpha Centauri is over 4 light years away. We know for a fact how far away Betelgeuse is. We know for a fact how far away Polaris is.
You
We
don't know
know
for a
for
fact.
a fact how far away the planets are, how far the sun is. Why? Because the model works. At the end of the day, that is the only question that matters in science.
In
Does
your
the
mind,
model
your
work?
models work. In your mind, they work, but they don't
No,
work
they
in real
do. I showed you not one, not two, not three, but 4 separate examples in this hangout of my model working. And your response to them was, well, I have to do it myself,
Oh, a
or
couple times, yeah. A couple times I said that.
or I'll just have to take your word for it. It's you don't have an actual valid rebuttal to anything I have presented. Like
I think
none.
you've convinced yourself about a lot of things that you believe in.
No, I
Um,
verified a lot of things,
no,
so I got to
I
correct
think you
myself.
verify it with the same um, disinformation, or not disinformation, wrong information that you started with. You just
Did
use the same bad information to convince yourself of your
did my Nikon
mindset.
P1000 lie to me?
I have a question. I have a question. I saw something that you posted the other day. You were filming. I think one of the rockets from Cape
Ar-
Canaveral,
Artemis one, yes.
Artemis one, and you said how beautiful it looked.
Yep.
Why did it look so beautiful? Just curious.
Because I am a fan of all things that are powerful. So fast cars, jets, rockets, basically anything that goes really, really fast and is really, really loud. I fucking love that shit.
Okay,
And
that's interesting. That's not the answer I was expecting.
yeah, I'm just a fan of high horsepower machinery, and that is the Artemis 1 rocket, the SLS, is an engineering example of pure badassery. I'm going to essentially strap a payload to a continuous explosion and get the fuck out of Dodge. I love that shit. It's amazing.
So you'd feel the same way about a rocket carrying a nuclear warhead.
I would feel the exact if it was aimed towards North Korea, oh, you bet your fucking ass, yeah. But if it's
This
if it's a
is
rocket,
this
if
is
it's a
something that
rocket
you guys
that's
have in common. You
if
guys
it's
are nihilists. You know, you're the globe Earth believers are nihilists. They want things destroyed. They don't believe in.
Thank you for that. Another repeated lie.
yeah. If we want
Okay,
to get if we
some
want
are.
to get into if we want to get into philosophy, then we can also
Okay,
get
no,
into
no,
the
no.
compass
I'm sorry. We
fallacy.
shouldn't have. I had a
Before
serious
we
question.
before going there is a chat that is in the chat. There's a question that came up a couple of times with the previous topic that Geo is now trying to run from. Geo, do you have
I'm not trying to run
experience
from
with
anything.
a nautical almanac?
I'm sorry.
Are you familiar with what a nautical almanac is?
Is that the distance of things measured in nautical miles? Yes
A
or no?
no would have sufficed there.
No.
And no, it's the reference material that's used for celestial navigation, which is dependent upon the known positions of stellar bodies in the sky. And guess what that document shows?
What does it show?
That the stellar bodies are in flux from year to year. That's why every year they release an updated one.
Also, a quick question, just to bring this up. Uh, uh, Gio, what classic car did you have?
It's a 1964 GTO.
1964 GTO. Is that car beautiful to you?
Well, yeah, I don't own it. It's just the car that I
Yeah, but
want
is
to
it
buy.
beautiful?
Yeah, it's one of my favorite cars. Yes.
Okay, why is it beautiful to you?
Well, I'm born in 1964,
Mm-hmm.
and in the grill of a GTO, it says the letters GTO, and I always said I'd change the T to an I, so it would say GIO.
I see. So it has some sort of personal relevance to you. Same is true for rockets for me, because when I
Yeah,
was
no, I
little,
get
my
it.
parents would
I get it.
take me to see the rocket launches and stuff like that. Maybe that's why I have a love for it. But the personal reasons why we love something is relevant to the fact that I filmed it. Anyone can film it. Multiple people have filmed it. That rocket lifted off. So my question to you is, what is your problem with Artemis? Like, what is your problem with the Artemis launch or the SLS rocket, or dare I say my footage? Because in my opinion, my footage is kind of badass.
Well, it was very pretty. Don't get me wrong; it was lovely to look at. It just, in my experience, all the rockets that I see, and I've heard the answers for this, or the alleged answers, the rockets go up and start to veer to the right, and then before you know it, they're on its side, and then they're even going down.
They
Like,
have to they have to go, they have to
uh,
curve. You don't
they have to
launch
curve
launch
down.
to space. You don't go to space by launching straight up. Who told you that?
So you go to space by going down, by
No,
putting your
you go to
nose
space
down.
by going sideways. You
And
go
it's
up high
it's funny
enough to
that
get.
it's funny that they all seem to head off to the Bermuda Triangle, where I think they've scared everyone to go to, or most people, and that way when they ditch them into the water, uh, no one sees it. I mean,
There you do realize that there's a guy called Astronomy Live. Astronomy Live, after he filmed right next to me, mind you, because his telescope was right next to mine. He filmed the launch of Artemis, but he does a little bit more than that. He actually caught Artemis in orbit and caught it when it was around the moon and caught it on its reverse trajectory back to Earth, where it is right now. He caught it. This isn't a theory. This isn't a guess. This is a brute fact that cannot be argued against. This is as true as water being wet and AT2 Productions being an asshole sometimes. It is true. We launched a payload to orbit. It made it to the moon. We know where it is. Its orbit has been solved, and all that information is on Astronomy Life's channel and Astronomy Life's Twitter page. In fact, just so that people know I'm not full of crap when I'm saying these things, because I like to be, thorough and honest with it and stuff like that. So what I'm going to do is I'm going to show you this shot right here. So I am going to bring this up. This is probably not going to be a good shot because it's on Twitter, but it's good enough for our purposes. Here is his tweet. This is one of his shots that he filmed with a telescope. And he is in the process of tracking Artemis, not just through launch, but through every phase of its mission. That circle, by the way, that circle that is around the craft, that was not drawn by him. That circle was not drawn by him. That is a prediction based on what NASA has said. We predict, given its speed, its trajectory, and the orbital or the gravitational influences of the moon and the Earth and whatnot, this is where the craft should be. If you point your scope at this part of the sky, it should be there. And when done in reality, it turned out to actually be the case. Though, I'm sorry, the Orion spacecraft is now not an anchor at the bottom of the Bermuda Triangle. It's
So,
currently in
okay,
orbit.
fair enough. Is that this picture that I was looking at? The circle is NASA, but the dot was him.
The dot was from the telescope. So
Okay.
so
How-
basically NASA said, "Hey, listen, we predict that the Orion spacecraft is going to be here." So Astronomy Live said, "Okay, let's go ahead and look at the coordinates of that. I want my program to draw a circle around those coordinates." Okay, so it does. So the scope moves in that direction, draws a circle around those coordinates, and it sees what it sees. If there's a craft there, we should be able to see it within that circle. And if we don't see it within that circle, then we know that NASA is full of shit.
okay.
Well, as we found out, it turns out that NASA isn't full of shit because we saw it. It was there.
So again, like the dot inside the circle is being filmed by your friend.
Yes.
Okay. Now, do they explain how thrust works in the vacuum of space?
Yeah, we know how thrust works in the vacuum of space. Every action has an equal and opposite reaction.
Including in the vacuum of space.
Yes, the medium in which the action takes place is irrelevant.
Well, that's not what I've read.
Well, then you've read wrong, my friend, because right here afterwards, this was a shot from Cape Canaveral. This was only 5 feet to my left after we filmed the launch of the Orion spacecraft on Artemis 1. This was an hour and some odd minutes later after the fact. This is its orbit after one orbit later, which means that after it launched, it was in orbit and it went all the way around the Earth and came back around again. And we caught it. We caught this shot. It is beautiful. It's fucking Mona Lisa. So after we captured the launch of Artemis, we confirmed that it put a payload into orbit. Then, using the burns of its thrusters, we confirmed that its orbit was such that it had an encounter with the moon. In order for that to even occur in the first place, rockets have to work in space. So, rockets, which were working in space, pushed the Orion spacecraft to a predicted encounter with the moon, which Astronomy Life was able to independently verify external to NASA. He doesn't work for NASA. Neither do I. We just said, okay, where is it predicted to be if this is turning out to be the case? Well, holy shit, it turned out to actually be the case. This shows that, yes, rockets work. It didn't launch a payload directly into the Bermuda Triangle. It went to the moon, and now it's on its way back. All independently verified, external from NASA.
What was the speed of the rocket?
Speed of the rocket going off, low Earth orbit is 17,500 miles per hour, which is around 28,000 kilometers per hour. To put that more simply, that is 4.7 miles per second or 7.2 kilometers per second.
Yeah, okay. And the speed between the Earth and the moon was going the same
It
speed?
varies depending on its
I'm
position.
curious. What's the maximum it goes?
The maximum it goes is probably on its way back. What is that, like 20,000 miles per hour or 21,000 miles per hour? Somewhere
Because
around
every time I see the supposed astronauts in space, they're floating around because there's no orbit. I mean, there's no gravity pulling them, right? They're
No,
just
there's
floating
gravity.
around.
There's just as much. There's almost as much gravity on the space station as there is down here on Earth.
Well, I don't see any of us floating around.
Well, the difference is that you're not falling all the time.
Yeah. Okay. Falling. Yeah. So, anyways, the Earth is going 66,000 or 100,000 kilometers an hour around the sun, and this rocket ship is only going 30,000. You're saying at the most?
We launched. If we're launching from a planet going 66,000 miles an hour around the sun, that would mean that we started from 66,000 miles an hour around the sun.
Right.
That's the first point, and a really obvious one at that. So let's say we were going out into space. What would make us lose that initial velocity of 66,000 miles per hour? Oh, is it nothing? By Joe, I think we got it. So that means since we're already at that speed, any thrusting or maneuvering or rocketing that we do is going to be in relation to that starting velocity. So when we're talking about going, 4.2 miles per second, that's relative to Earth. Relative
Now,
to the
is
sun,
the
it's a totally different speed. That's a
when
different
when
question.
when the rocket is out of Earth's orbit, is it aiming right at the moon?
No, it doesn't aim. You don't go to the moon by shooting directly at it. That's stupid.
Okay, and so it's realizing that in the 3 days that it takes to get there, is it 3 days, 2 days?
I think it's what was Artemis? I think it was like 4, 5, 6, something like that.
Okay.
Yeah, but yeah, it takes days to get to the moon. But yeah,
How
you
many
don't
days?
go to the moon by firing your rocket directly at it.
And,
You would
and,
never make it.
then while it's in space past the moon, it has the ability to turn around and go back to the Earth. Is that right?
It has the ability to use the moon's gravity to adjust its orbit and put it on a trajectory that encounters the Earth.
And
Yes.
you believe that?
Oh, not only do I believe it, it's been independently confirmed.
Yeah, independently confirmed.
Yeah, it has been.
Oh,
It's not a matter of
Red,
belief.
red,
I don't
red.
believe it. I know it. This is a
Okay,
brute fact. You
red.
cannot
You know what?
deny.
I'm losing my voice. I don't normally talk this much. I don't want to cop out. I just have one thing. If you want to ask one more question, then I want to ask one more question, and it might upset people.
That's perfectly fine. We'll go ahead and yeah, because we've been going for an hour 45. So I'll leave it at this.
Okay.
I will make one more statement. I'll ask you one question after you ask yours, and then we'll call it a day. But as far as Artemis, it's not a matter of belief. I highly recommend you look up a channel called Astronomy Live. He also is retweeted constantly on my Twitter page. You can scroll down to all of his tweets. He is posting real-time updates of his observation of Artemis to show that it is actually doing what NASA says that it is doing. This is not a matter of opinion. This is not a matter of
Okay.
group consensus.
One
He
little
is
side
doing
to
this
that.
himself.
Is he showing? Is Artemis taking film of all the other satellites that it's passing as it goes through into space?
Why would no? He can't see them. They're too small.
Too small?
Yes, correct.
Okay.
So,
Or is it because there's none of them are up there?
oh, that's very, very shocking considering I filmed many of them myself. One of them being the International Space Station. So
You should go take a look at that Baumgartner flight. Like I said, the balloon itself was 55 feet long. I think you might be seeing some of those.
Yeah,
anyways,
except with the naked eye, you wouldn't see shit. You would need
you
would need a telescope and need to know exactly where it is in order to find it. Anyway, let's go ahead and try this. What is your final question?
Okay, my final question is this, and it's going to be from the Bible. So if there's any of you who just completely refuse to believe the Bible, I understand. Either turn the volume down or walk out of the room. But this is if there's any of you out there listening that are Bible believers, okay, this is for you, because it says in the Bible in Genesis 1 that in the beginning God created the earth, the heaven and the earth. In the very beginning, the heaven and the earth, okay, and darkness was on the face of the earth. Something almost sounds like something happened between the beginning and then our creation, but that's another debate. So it says that God said on the first day, let there be light. On the second day, he divided the waters. On the third day, he put the firmament. Maybe that was the second day. But my point is this: on the fourth day of creation, and this is for the Bible believers who believe the Bible, but they believe that the earth is round. On the fourth day, he created the two lights in the sky, one for the day, one for the night. That's the sun and the moon. And he put them in the firmament along with the stars. Now, for those of you who believe the Bible but don't believe what was the earth doing before the sun was made? Like, was it just revolving around on an orbit without a sun? And
the earth wasn't here before the sun, though.
I'm sorry?
The earth wasn't here before the sun.
Yeah, according to the Bible, it was.
The Bible would be okay. That's just another thing the Bible got wrong, then. But whatever.
What's
the question here, though?
I'm not saying this is for you, Red, because maybe you don't believe in the Bible, or maybe you believe it has errors. I don't. This is for the people who believe the Bible is true and doesn't have errors, and anyone else doesn't have to listen. But the Bible says,
I'd love to talk to you about that later.
Yeah, that's fine. Maybe we can have a discussion too. So what I'm saying is that the Bible says that the earth was here first, and then on day 4 of this creation, God put the sun. So we were actually either revolving around something that wasn't there, and if we were revolving, it was supposed to be gravity that was keeping us in that orbit. But you see the contradiction. There's a conflict there, and then at least 75 times in the Bible it says that the earth is stationary; it doesn't move. Many times in the Bible, it'll say, well, here's one of the things in was his name there? The guy who was with, I'm having a bad memory day. Anyways, he demands that the sun and the moon stand still, not the earth. He demands and those who know the Bible will know the passage I'm referring to. So throughout the Bible, and even in Solomon says that there's nothing new under the sun. So many times through the Bible, it's telling you that the earth is stationary, it doesn't move. In Isaiah, it says God looks down on the circle of the earth. Circle is not a sphere, because in Isaiah, he talks about
two-dimensionally it is.
I'm sorry?
A two-dimensional sphere would be a circle.
Well, he didn't use that word because
I don't.
Later on, hang on. Later on in Isaiah, he
Get
says,
to the question.
Yeah, what's the question, dude?
Well, like I said, throughout the Bible, there is multiple proofs that the earth is stationary. God says in Isaiah, I'll roll you up as a ball. So he doesn't use that word. And like I said, the earth was created before the sun. And this isn't for you guys. Okay, don't worry about it. This is for the 1 or 2 or 10 or however many. But this is a show where you're talking to me, not them. Again, they can you
ask
invited
questions, but here's the thing: we're here to talk about one thing.
No, but Red, you invited them, so I feel like
they're allowed to watch this show. I invited you to talk to me, not preach the Bible, dude.
No.
I invited you to give me
the
best pieces of evidence.
This is not for
to
you.
Show that the Earth is flat. You have not been able to do that. You've been sending misunderstandings and basically just assumptions.
I think I said I got my point across. So go ahead. Give me your last question.
Whatever the point.
Can I ask it?
AT2, I'm going to ask you to shut the fuck up for a second. So here is my final question.
Sure.
Let's say the Bible said explicitly, absolutely explicitly, without any question whatsoever, the earth is flat. The earth is 100% flat. It is not a sphere. It's not a donut. It's not a tetrahedron. It's not anything. It is flat. The Bible said that explicitly to the point where it could not be misinterpreted as anything other than the Bible says the earth is flat. Now let's say that I got in with a shit ton of money and I was able to fly your happy ass all the way to space so that you could see our beautiful round earth. Would you believe in that case, in that hypothetical, would you believe your own eyes or would you believe the Bible?
Well, the Bible never says that the earth is actually a globe or flat. It does say it's stationary. And this is why it was very important. It was very important for me to say that. The Bible never says.
Yeah, but in this hypothetical, we're assuming that the Bible says explicitly that the earth is flat. So if the Bible says explicitly that the earth is flat, and I send you to space and you see that the earth is actually a sphere, would you believe your eyes or would you believe the Bible?
I would believe my eyes, and I'll tell you why. Like I said, the Bible never says that it's flat. It just says that it's stationary. So
but in this hypothetical, it does. In this hypothetical, it does say it's flat.
You can infer that it does. You're right, but it doesn't actually come out and say that.
I'm not saying it infers anything. I'm saying in this hypothetical, we are saying that the Bible explicitly says that the earth is flat. The Bible explicitly says all this.
I believe my eyes, Red. I would believe my eyes.
Perfect. Then you believe your eyes. So if
Yeah.
we are of the position that our eyes, our measurements, the things that we can, empirically see to be the case that contradict the Bible, and we should go with that and not the Bible, then the Bible, by your own standards, is useless in this debate.
No.
We're talking about
There are a lot of
empirical
ifs there and a lot of hypotheses.
No, we're talking about empirical data, and you and the Bible is not empirical data. I'm sorry.
According to you, it isn't. And look, I'm not here to proselytize, okay, to you.
Seems like it.
But I may be here for the 4 or 5 people that might be out there thinking, you know what? I get it now. I'm here for them, Red. So I'm not going to.
You can always do your own YouTube channel, and then you can preach. But here, the thing is that when people come to this channel, they're looking for something similar to a science lesson with a lot of extra cursing. They're not looking to be preached at. If people want to be
I realize
they go to Jeranism.
I realize that, but like
Jeranism is very good at preaching and being the flat earth priest or whatever. He's really good at preaching. So if you want to preach, you're going to do that on your own channel. But here I asked for something explicit, which was evidence. The Bible is not evidence.
You and I both know this, Red. And we've seen other debates and we participate in other debates. You and I are not going to convince each other anyways.
That's not the point. My point here is not to convince you. My point is to show something. My point is to show that when given the platform and the opportunity to present evidence for your model, you will not be able to do it. That's what I want to show. I want to give flat earthers every opportunity.
You'll use an argument that says that that's not true anyways. I've had so many debates about multiple subjects. And every time somebody yells, give me evidence, prove it. You prove it, and they don't believe you anyways. So I'm beyond that. This was a discussion, say ideas. I don't believe in a lot of the evidence that you've put forward to. I think it's sleight of hand, cartoons, animations. You didn't show me anything either. But I will look into some of the things that you presented because I'm curious, and I am still a student. Hopefully you are too. And my mind is open to truth. As a matter of fact, one of the earliest believers in the globe Earth was Aristotle, right?
Good
Aristotle, and he only believed that because he would see the ships go on the horizon and seem to go down, but he didn't have that nice camera that you have, that if he would have actually zoomed in, he would have still seen the
P1000 isn't a nice camera. The P1000 is not a nice camera. Here's what I'm going to say.
Yeah.
Being that we're here for empirical data, I'm going to say this right now. Tonight, Astronomy Live is going to be doing a live stream of Artemis through his telescope in real time. You'll be able to see this for yourself. We literally provide everything at your fingertips to the point where you don't even have to do the work yourself. All you have to do is show up to the live stream and see what the telescope sees. That's it. This is something that is more powerful than any Bible verse. This is something that's more powerful than any religion.
That's your opinion.
No, this is more powerful than any religious text from
whichever part of the word religion comes up too liberally. Everyone has a religion. You don't need a God.
The Bible is a religious text, dude. So is the Quran. So is whatever other holy text is out there. The fact of the matter is that
religion, by definition, is a worldview based on faith. You don't need a God. A worldview based on faith, and yet that seems to be flat Earth in a nutshell. So and globe Earth as well.
No, globe Earth actually has evidence for it. That's the difference. When we look at, and that's why I brought up everything that I brought up here today. I wanted to show that if we were to look at the evidence, which I presented, and we were to show what is predicted by the round Earth model, and it shows that it comports, that shows we actually have something going for us here, something that is beyond faith. That is, yup, that's definitely a curve, and I'm not going to lie to myself by assuming that that curved bridge is somehow flat because I'm misunderstanding the law perspective. It's not. That's not the way it works. I am going to read this super chat real quick. For £5, Warren says, if the Bible is correct and God is all powerful, why couldn't God defeat
the Canaanites?
Canaanites?
Canaanites.
Oh, okay. Because they had iron chariots. Judges 1:19.
Why couldn't they do what? Because they had iron chariots?
The super chat is on screen if you want to read it yourself.
Sorry,
I may
so
have
I'm
read
actually
it like
looking
shit.
something up so I can post it.
If the Bible is correct and God is all powerful, why couldn't God defeat the Canaanites? Because they had iron chariots. Judges 1:19.
Because he commanded the Hebrews to do it, and the Hebrews didn't quite do it, and that's why that land is still cursed. Oh, sorry.
Sounds like if you have God in your corner, he should have given you a little bit of a boost there.
No, I'm trying to look something. Okay, I have the clip, and this is one of the reasons why I don't believe anything from NASA. So I've got too many windows open. Okay.
The question here's the question though. Did I go to NASA at all for any of the observations that I personally made? Or did Astronomy Live go to NASA for any of the observation that he personally made? We didn't.
No, I don't think you did.
No, we didn't. So I'm just going to say, I'll go ahead and look at whatever is troubling you about NASA, but just so that you're clear, NASA could die tomorrow and it would do nothing for my arguments. They could have died last week and it would have done nothing for my arguments. Just pointing that out there. But
well, I'm saying that the same people who do the stuff from NASA can do it. There's a possibility, or there's a plausibility.
Did you intentionally mispronounce that to sound like the Hebrew word for deceive?
To seed?
Deceive.
Deceive.
No. I'm losing my voice, so if I sound a little hoarse, I'm not used to talking this much.
That's fine. Well, how about this? I'll let you have the final question, then we'll end it. So go ahead.
Oh, okay. No, my final question. And Red, don't get me wrong. I appreciate you doing this, and I like that you have information too. Because, like I said, I'm a student in this. I studied this a lot, especially over the years, but especially the last week. I actually got tired of it. I got sick of it. That's why I didn't. When you said let's delay it, I said, yeah, I couldn't be bothered. Anyways, I'm more convinced now that the Earth is flat and stationary. But I think that there's a lot of obfuscation on both sides. So it's going to take a long time for both of us, I believe, to really come to a conclusion. And then maybe you're on one side and I'm on the other side for the same reasons. So, but like I said, don't let me think. Don't think that I'm whatever you're saying. I'm poo-pooing any of that information. I'm not, and I don't want to come across it as. But I do in my. I'm just not able to present as well as you do because I had some videos and I had some. I'm just not good at putting them together. I don't have the software for it, and I'm 58 now. I don't know how to do that stuff. But I had a lot of good information for you, so I wish I could have done a bit better. But I do believe more than ever that the Earth is flat. So that's my last 2 cents. And like I said, for the Bible believers out there is that thing that the Bible says that the Earth is stationary multiple times, that the Earth was made before. So how do you reconcile that with a globe Earth? And that's my last words.
Okay, so 82, that super chat that was at the very beginning about altitudes. If the sun is small and local, shouldn't we experience a temperature increase as altitude is also gained? Once you answer that, I'm not going to respond to it. I'm just going to let it sit there, and then we end the stream.
Well, we do experience temperature change as the sun is no longer over us, but that's a better model than the fact that we're 93 miles away from the sun tilted. So the north is a little bit warmer than the south because we're 93 miles and 1,000 miles closer. I mean, that doesn't make sense. the globe Earth, well, the flat Earth says that the sun is local. It rotates between the tropics of Capricorn and Tropic of Cancer, but it doesn't say that the sun is our only source of heat. By the way, so there's that. There's a lot to learn, guys. There's a lot to learn.
Okay, so
finally, something I agree with.
Yep. All right, so we're gonna go ahead and end this.
Okay,
so...
but before we end it, give Red a super chat, guys, and AT2.
Sounds like a plan. I appreciate. So AT2, I am going to give you a chance to say what you guys say, and then yeah.
No, I'm just sitting here looking out this hotel at Mountain Pass that between 3.5 and 4 miles away. Wondering why I can't make out the shape of the cars they're driving on that road.
Interesting.
Why?
All right, guys. Thank you very much for watching. Thank you very much for being here. Gio, we'll do this again sometime. So for now, I will talk to you later, Gio.
Keep in touch.
Okay, so guys, thank you very much for watching. Thank you very much for being here. That was a dumpster fire as expected, but it is what it is. I do want to thank AT2 for being a referee. It was wow. So I'm going to finish off with the final 2 super chats. If I missed any, I do apologize. We do our best, but as you know, sometimes I just fuck up. Dora for €2 says, a student that didn't do any work. You failed, Geo. Thank you very much for the super chat. I do appreciate it. And Slick666 for £2 says, why follow the Bible? 2 Kings 2:23-24 sick. What is that? Let's
From here, Elisha went up to Bethel and so what he's referring to there is the quick little story in the Bible where God smited a couple of dozen of children simply for making fun of a bald man.
Oh. From Elisha went up to Bethel. As he was walking along the road, some boys came out of the town and jeered at him. Get out of here, Baldy, they said. Get out of here, Baldy. He turned around, looked at them, and called down a curse on them in the name of the Lord. Then 2 bears came out of the woods and mauled 42 of the boys. Holy shit. Okay.
But all loving God.
We're going to leave it at that. Thank you very much for watching, guys. Have a good one. Bye-bye.